Alright, so this is test 2-2 review, and I left my review on my desk, so I just wrote all the questions down. So I'm going to go through it like this. So this is problem number 1, and this test is mainly all over our quadratics unit. The first problem they give us is an equation of a parabola or a quadratic function, and this is in vertex form, and the way you can tell is you have the parentheses and a squared in it, and you can automatically see what the vertex is just by looking at it. So the first thing that they ask you to do, get some more paper. The first thing they ask you to do is to put it in standard form. So all you need to do for standard form, guys, is you just need to FOIL and simplify. So I'm going to rewrite. So remember, here you cannot distribute. I told my kids that makes me really sad. You cannot distribute that. You have to rewrite this as x minus 3 times x minus 3 minus 7. So the first thing I'm going to do is I'm going to FOIL these two guys right here. And the -6 and the -7 are just going to chill for a second. So when I FOIL this out, I get x times x is x squared. Outer you get -3x, inner you get -3x, and then last you get -3 times -3 is a +9. So I'm going to check to see what I can smush. These guys right here, I can smush them because they have the same last name. They're common like terms. So I end up getting x squared minus 6x plus 9. This is still all in parentheses. I'm going to bring down what I had left over. So I have -6 here being multiplied. And then bring this down, you subtract 7. Tell my kids now, what are your math spidey senses, thinking back to Algebra 1 PEMDAS, what are your math spidey senses telling you to do? You're going to distribute this -6 to all three terms. So you get -6x squared plus 36x minus 9 times 6 is 54 minus 7. Sorry, my pen's going out. And then I'm going to rewrite. I can now smush these guys. So I have -54 minus 7 is -61. And that is how I write it in standard form. I have an A, B, and C coefficient. So this is y equals -6x squared plus 36x minus 61. Alright, so that's that one. Part B says they want to know what is the vertex. So that's straight up by looking at it. Remember, in parentheses, this is horizontal land, so it's the opposite. So this would be 3 and then -7. Your axis of symmetry is always going to be your x coordinate of your vertex. It's where your parabola, if you cut it in half, it's symmetrical over itself. And that always, for this case, is going to intercept the x-axis. So this is going to be x equals 3. Our domain, so if I was just to do a little sketch on the side, so this would be at vertex is 3, -7. You can either draw this on your calculator. I like to draw a little sketch. It's going to be a vertical stretch of -6, but the negative in the front means it's going to open downward. So I'm just going to draw a little sketch so I can see. I like always seeing a graph of the function. That's just kind of how my mind works. So our domain is how far left and right it goes. So that's from -infinity to +infinity, or you can write all real numbers. Our range is from bottom to top if you're doing interval notation. So it's going to be -infinity, that's the lowest it goes, all the way to -7, and that's going to be a bracket. Or we could have wrote it as y is less than or equal to -7. So we have a maximum right here. Our maximum point is at our vertex, which is at 3, -7. And it wants to know what is the maximum value, so that's going to be -7. This opens down. It opens down because we have this negative in front of our coefficient. So your A is negative. And that's it. That's number 1. Alright, so I am skipping down to number 3. So here they want us to write down what are the transformations. So for number 3, I have this negative in front, so that means it's going to reflect or flip the x-axis. Or you can call this a vertical flip, because it's going to go from here to here. So it flips vertically. And then it's a vertical stretch by 4. So that's the answer to number 1. Or part A. Part B, this part right here is an horizontal land, so it's going to go, it looks like it goes to the left, but it's actually, you're going to go right 6, and then on this guy is going to go up 4, because it's outside the parentheses. This is part B. Part C, right here, so it's going to, again, reflect over the x-axis. You have a 1/2, you're in you're in vertical land because it's on the outside of the parentheses. So it's going to be vertical. Since it's less than 1, it's going to be a compression by 1/2. So that's part C. I don't know why I keep using this pen. Let me do this one. Okay, so D is, okay, you have a negative on the outside, so that's going to reflect over the x-axis. And then you have a negative on the inside, so that's going to also reflect over the y-axis. So it has a double reflection. And then that's it. That's it for D. For E, so I have this 2 on the outside, that's vertical land, so it's going to be a vertical stretch by 2. You're going to go, it looks like you go right 3, but it's actually left 3 because you're in horizontal land and it's opposite. And then -7 means you go down 7. That's vertical, you just do what it says. So that was E. And then F will be over here. Last one. So this one, since it's out, like this is its own little parentheses, this is on the outside, so you're just going to go down 4. Alright, so let's go ahead and do number 4. Here they give you a vertex and then a point, and then they want you to use your calculator to figure out the regression equation. You guys remember from class, from the notes, in order to use your calculator for the regression equation, you must have at least 3 points. Because if you don't, it's going to think it's a line. So what you're going to do is, I'm always going to draw a little sketch. They tell you your vertex is 4, 3. And then they tell you have a point 2.7. So here's 2.7. Well, this is my vertex, right? And this went 2 over up. I'm going to go 2 over this way and then go up to find the symmetrical point. So this would be 6.7 right there. Because this is the axis of symmetry, and your parabola is going to look like this. So I have 3 points. So I'm going to switch over to my handy dandy calculator. So here it is. Let me zoom out just a little bit so y'all can see. So I'm going to go y equals, I'm going to plug in, sorry, not y equals, go to stat, edit, there we go, and do my points. So my x coordinates are 2, 4, and 6. And the corresponding y coordinates are 7, 3, and 7. Make sure they all match up, right? 2 goes with 7, 4 goes with 3, 6 goes with 7. So then I'm going to hit my stat button again. I'm going to go to calculate. And we used to go to linear regression, but now I want to go to quadratic regression. Hit enter, and there it is. So my regression equation is y equals, your a is 1, so it's x squared minus ax plus 19. So that's your equation in standard form. Our symmetric point was the one we found, so that was 6, 7. Our axis of symmetry is where it's going to cut the x-axis. So that's x equals 4. It's our x-coordinate of our vertex. Our domain is all real numbers. Because for parabola, it goes to the left all the way to infinity and to the right all the way to infinity. So you can write it as all real numbers. You can also write it as interval notation from negative infinity to positive infinity. And our range, remember, is always bottom to top. So the lowest that our graph went was 3, closed, and then all the way to infinity. Or in Set Builder, I could write it as y is greater than or equal to 3. So part F says, is this a max or a min? So remember, mins look like holes in the ground. Like if you're walking, it looks like a hole, like you would fall. So this is a min. Max looks like mountains. So this is a min. And it opens up. That's it. All of number 4.